Good morning to all. I hope every one of you understood what and all we have seen in the last videos and the concepts, formulas and also examples. So which and all we have seen in the last class. I think every one of you understood about that. And today we are going to recap some definitions first on probabilities, and then we are going to enter today's session, right? So let us start with the basic concepts here. So the title is probability. So as I told earlier, probability or chance of getting something, right? So here under probability, the events everything or the experiments everything unpredictable one. That is we have assumed, okay, we have assumed anything. The anything may be happen, right? So that's why the definition of the probability is nothing but chance of occurring or not occurring of an event, okay? So which event and all not predictable before itself, then all the events comes under the word probability, right? So let us recap the formula first. So probability of any event is nothing but P of E equal to number of favorable cases divided by total number of cases. So here we can define this formula in notation also, that is N of A by N of S. A is the name of the event, okay, and S is nothing but sample space. And what is sample space? So sample space is nothing but the collection of all the outcomes of an experiment. And in the last class I have explained the difference between experiments and also events. So experiments is nothing but, what are the experiments? Tossing coins, throwing die, selecting something from the box, numbers or anything. So everything called experiments. And the outcomes. So the outcomes of the respective experiments is nothing but events. So in tossing coin, what are the events? In tossing coin, only the two elements are there, that is head and tail. When you're tossing the coin, so the coin may shows head or tail. So they are the events. If you want to find out one by one, means in the same question, so we can assume them as E1 and E2. That is event 1, event 2. If you want to find out the probability of that particular event, E1 means, so P of E1 equal to. So we have to apply the formula. As already, actually in the last class itself I already told that if you want to find out the probability of any event, we need the sample space. So sample space and also event. So number of sample space will be in your denominator of the formula, and the number of events will be the numerator of your formula, okay? And then next throwing die. So what are the elements when throwing a die? So 1 to 6 numbers. So the set of numbers 1, 2, 3, 4, that is within that 6 numbers is nothing but the event of throwing dice. Okay. So likewise we can differentiate experiment and events. Okay. So before solving any probability questions, so what type of experiment and what are the events of that particular experiment will be given. Just identify that. Okay, then after that you can use the respective formula with the necessary steps. That is very important, right? Okay, now look at the properties. That is the new thing here. So in every topics properties will be there. Okay, similarly probability also some properties are there, right? So the first property, before going to see the first property, I am going to ask one question here. That is, suppose if you are tossing a coin, right? We are going to tossing a coin. So that is an experiment. So only one coin we are going to toss. Suppose the question is, what is the probability of getting hit? So that is a question. Okay. So what is the answer? So the head is nothing. What are the possible cases when you are tossing the coin? So two cases will be arise, right? So one is head and another one tail. Okay, so these are the possibilities of when tossing a coin, right? Suppose the question is, what is the probability of getting head? Means we can count the elements. Okay, how many heads are there? So only one head is there, so the probability is 1 divided by 2. So that is the probability of getting head. And what is the probability of getting tail? The only one other than head is nothing but tail only there. Then what about the probability of this one getting tail? That also will come 1 by 2. Now what about addition of these two probabilities? Right? So this 1 by 2 is nothing but the probability of getting head. This 1 by 2 is nothing but the probability of getting tail. So here I found the sum of the probabilities of all the events. Okay, when you are tossing coin, only two events are there, right? So that 1 by 2 is the probability of getting head, and one more 1 by 2 is the probability of getting tail. If you add these two probabilities, so the answer will be 1. So from here, okay, from here we can derive one property, that is sum of probabilities of all event of an experiment equal to 1. If you take any one experiment and just list out all the possible outcomes and find out the probability of each one and add everything, the result will be 1 definitely. We can check with any other experiment. So let us define another example. Suppose when you are throwing a die, okay, when you are throwing a die, what are the possible outcomes? So 1 to 6 numbers are there, okay. So the sample space is nothing but 6, okay. Now the question is, what is the probability of getting head? Sorry, what is the probability of getting the number 1? So what is the probability? The total number is nothing but 6. So how many times that 1 will occur on from 1 to 6 numbers? Only one time. So the numerator is 1 and the probability is nothing but 1 by 6. Okay. Next, what is the probability of getting 2 when rolling a die? So how many 2s are there inside that? Only 1 2. So the probability of that also 1 divided by 6. Similarly, what about the probability of getting 3? So only 1 3 is there. Then that also 1 by 6, right? 1 by 6. And what about the probability of getting 4? That also 1 by 6. And what about the probability of number 5? 1 by 6. And finally, the probability of getting the number 6 also 1 by 6. Now, if you add all the results, all the probabilities, the result will be equal to 6 divided by 6. So 6 divided by 6 is nothing but 1, right? So the answer is 1 here. So if we add all the probabilities of all the events of an experiment, so that will be equal to 1. That is a very important property in probability. Okay. So next one. So that is a formula. Okay, P of E plus P of E bar equal to 1. Already you know that what is E, but what is E bar? So E bar is nothing but it is a complement of E. So complement of E is nothing but is a opposite. For example, let us take the same example. This is tossing a coin. In tossing a coin, head and tail both are the events. In that, suppose we will expect to getting head means the remaining event is nothing but getting tail. So that tail is nothing but your E bar. That is complement. That is other than the particular event. That's it. Okay. Similarly, when you are throwing die, 6 numbers are there, right? 1 to 6 numbers, right? Suppose my question is, what is the probability of getting odd numbers? Okay. So odd numbers means 1, 3, 5. What are the remaining numbers? 2, 4, 6. That is even numbers. So the set of even number remaining is nothing but your E bar. Okay, so the E bar is nothing but complement of E, that is the remaining event other than E, that is the meaning. Okay, in the similar way, suppose in a box, suppose 1 to 10 numbers are there, 1, 2, 3, just up to 10 numbers are there. For example, okay, in a box, so 10 numbers are there, right? Now I am going to take odd numbers alone, or I am going to take first 4 numbers, okay, that is 1 2 3 4, or you can do like this. Now I am going to take only prime numbers. Okay, the question is, what is the probability of getting prime numbers out of 10 numbers? Okay, so what are the prime numbers starting from 2 onwards, right? So 2, 3, then 5, then next one 7. So that's all, isn't it? So these 4 are the prime numbers from 1 to 10. What are the remaining numbers? So 1, 4, 6, 8, 9, 10. So these remaining numbers, everything. So the remaining set numbers are called E bar. Now understand? So E is nothing but one of the particular event, and E bar the set of remaining events. That's it. Okay. And next one is nothing but probability of an impossible event. So what is the meaning of impossible event? Suppose if you are tossing or if you are rolling a die, okay, rolling a die. So what are the possible numbers? 1 to 6 numbers. Suppose the question is, what is the probability of getting the number 7 when you're rolling a die? This is the question. Is it possible getting 7 when you are rolling die? Not possible. So the answer is 0. Right, so that is called impossible event. So the that is, it is not possible to occur. Okay, so that is, so what is the probability of that kind of events is nothing but 0. Okay, then next, finally, the limitation of the probability. So 0 less than or equal to p of e less than or equal to 1, that is the probability lies between 0 to 1 only. Okay, so the maximum value of a probability of any event is nothing but 1, and the minimum value of any event, that is the probability of any other event with minimum case is nothing but 0. Right, so these are the three very important properties on probability. So let us list out once again. So first one, sum of all the probabilities of any event is 1, experiment is 1. And second one, the probability of an impossible event is 0. And the third one, the limitation of the probability is 0 to 1. That's it. Okay, so these are the very important properties, right? So next we are going to see one example. So look at the question. An insurance company selected 2000 drivers at random in a particular city to find a relationship between age and accidents. The data obtained are given in the following table. So this is a table. So the table shows what information. So the first column is nothing but age of drivers, okay, in years. Okay, they are in 3 categories. And number of accident in 1 year. Okay, so 0 means no accidents are occurring. Okay, and here only 1 accident, 2 accident, 3 accidents, so more than 3 accidents. That is the meaning. For example, if you take the number 65, means the 65 mentioned that the age group 29 to 50, the age group from 29 to 50 of drivers, they met an accident 65 times. That is the meaning. That is 2 accidents. So 2 accidents in 1 year is nothing but how many times? 65 times. That is the meaning. And here 390 means, so above 50 years old drivers didn't meet any accident at 390 times. That is the meaning. You understand the table now? Right. Now we are going to find out the answer for the following questions. So find the probability of the following events for a driver selected at random. So what is the question? First question, being 18 to 29 years of age and having exactly 3 accidents in 1 year. So 18 to 29, so from 18 means this range only. So this range, but exactly 3. So exactly 3, right? So the corresponding number is nothing but here 3, here 18 to 28 is nothing but 70. So the answer is 70 divided by 2000. So total is nothing but 2000. That's why. Okay. So let us see the next question. So 30 to 50 years range. Okay. 30 to 50 years range and having how many accidents? So 1 or more accidents. 1 or more accidents. So 1 or more accidents means starting from, so here onwards, right? Here onwards and fully, right? And then the age. So the second row, that is 29 to 50, that is from 30 onwards. So we can add everything here from 118 onwards. Okay, so we can add everything here. So when we add, so 118 plus 65 plus 20 plus 21 equal 224. The answer is 224 by 2000. Okay, and what about the next one? Having no accident in 1 year. So having no accident in 1 year. Okay, so having no accident means, so here 0. So these 3 cases in each category, that is 18 to 28 no accident 395, and 29 to 50 520, and above 50 ages 390 times no accidents. So we can add all the 3 numbers here. So 395 plus 520 plus 390 equal to 1305. Okay, divided by 2000, right? So that is a procedure to find out the probability of the given things, right? So let me continue from the next video.